everyone. My name is Victoria with Visual Studio Magazine and ADT Mag, and I'd like to thank you all for joining us on today's Regulations Roundup, navigating SBOM and OSS compliance across the U.S., India, and Europe. Before we begin, I'd like to cover just a few housekeeping details. We will have a Q&A session at the end of today's event, so please type any questions you have in the Q&A box, and we'll do our best to get them answered for you. Revenera has also provided some resources which do correspond with today's event, so take a moment to check those out. They are located on the right-hand side of your audience console. I also want to mention that today's webcast is being recorded, so make sure to keep an eye out for a link in your email to rewatch the presentation or to share it with a colleague. And now I'd like to introduce you to our speakers. Today we have the pleasure of hearing from Dr. Andreas Katula, founder and managing director of Bitsy, Leon Schwartz, principal at GTC Law Group, and Venkat Ramdanga, product management director at Revenera. So we're in for a really great event today, and with that, I will pass the time over to Venkat to get us started.
All righty. Thanks, Victoria. And thank you, Andreas and Leon, for joining us today. So today we're going to do a quick overview of what regulations are across the world, and how we as brand ambassadors of usage of open source are either geared up for it or we're not, right? So let me quickly go to the next slide. All right, so I think we are at a stage where we do not probably require an introduction of what an SBOM is, but for those who are for the uninitiated, so an SBOM is nothing but a software bill of materials, a formal machine-readable document that can list down all third-party software that is included in your software. Now, why is this really important is because of the core problem. The core problem is that modern software is not just your own code, but it is a culmination of what you have in your code, and a large part of that is the hidden dependencies or the hidden 70 to 90% coming in from open source software. And what is this causing? So this is primarily causing a visibility gap on organizations who are consuming software. Hey, I've procured this from somebody. Am I exposed to a potential threat or not? And with that comes a business impact, which is not so easy to derive or quantify. But if you talk in terms of dollars, we have some examples so that Andreas here will go through where people had to pay huge penalties on some of these items, and how today we're trying to understand how regulations will help us stay on course in order that we don't have this so-called business impact, right? And what do they actually lead to? Lack of any checks and balances in trying to generate these SBOMs and manage these SBOMs. What do they really lead to is risks in the entire software supply chain. So, Andreas, can you touch base on what are the various risks we already encountered or ran into, or the world has ran into, before we go into the regulations as per se.
And I think, sorry, I'm going to jump in here, Andreas, before you do, but one of the things, Venkat, that I think is super interesting these days is the way the software world is changing, right? So we have all of these AGI tools, right, that generate code, and that combined, so they're being trained on open source code, and they're generating their own open source code, and sometimes they're generating exactly what they were trained on, right? And there are all of these license implications because of that. And because of the curious way in which open source licensing works, and again, I assume that everyone here knows what that is, but just in case, open source licensing is a little bit different than your typical commercial software licenses that we see every day. There are no sub-license rates. So that means that the original licensor, the original copyright holder, has a license with everybody up and down the supply chain. So that license goes to the original licensee, and then if that person redistributes the piece of software to somebody else, that original license applies to that end user as well. And for this reason, right, everyone in the supply chain is responsible. Everyone has to comply with the same terms, and that's why all of this that sort of that hidden part of the iceberg on the previous pages is so interesting.
Absolutely.
Yeah, thank you, Leon. Yeah, to get started on the regulations that we have around the world, for me, the first question is, why do we need these regulations at all? And why are they there? And I would like to start with the risk landscape that we currently have. And I've put together some of the recent incidents or cybersecurity attacks. The first one that I would like to mention is on the very left side. You see this bleeding heart. That's now almost 12 years old when it first appeared. And that was the first time when people realized that in open source, there are security risks that were not very well known before. And we still find code that has these old vulnerabilities in there. So the heartbleed was just a component somewhere in the background. Two computers were talking to each other, and attackers could manage to get into the computers and get like root access rights. Struts2 I will talk about in a minute. SolarWinds is one of the most favorite, and this is one of the reasons why we have these regulations in the US and in the EU and India. SolarWinds, a big company you may all know about SolarWinds, they produce security software. And what happened to them is that attackers did not directly attack SolarWinds. They took an open source component and they put a backdoor in that component, and they just waited until SolarWinds had integrated that component into their code, into their system. And SolarWinds is a supplier for many of the public services of the government, and they automatically rolled out their newest release to all their customers. It was more than 40,000 different customers. And suddenly all these customers had this vulnerable component with the backdoor, and the hackers could easily attack all of these customers. That was very dangerous, and it was a very big attack, and was one of the root reasons why the executive order had been published. A more recent one is Log4j that you may all be aware of. It is a problem of Java systems. Log4j is a component that is used basically everywhere when you have Java. And it also had a security vulnerability so that attackers could get root access to the computers. And here the risk was a little bit different. The risk or the problem was that the community that supports Log4j is very small. It was just a handful of developers who supported Log4j in their free time. And they were not available to create a quick fix or a patch. And it took several rounds until that problem was fixed. And then, of course, very recently, the Shai-Hulud problem that we will talk about a little bit on the next slide. It was, I think it's just 2 or 3 months old when it first appeared. And that worm is a perfect example for a supply chain attack. In Shai-Hulud, the attackers managed to steal the credentials from one GitHub user, and they could enter malicious code into the repositories, into the NPM repository. And from there, whoever downloaded that new version that they created, they got automatically infected, and the code stole their credentials as well and tried to find out username, stole the tokens, and then infected all the repositories that they had access to. And it multiplied very, very quickly throughout the different NPM environments. I think within a day, there were more than 40,000 repositories infected with that malicious code, and it was quite difficult to get rid of it again. So this is one of the newest one. One of my favorite is the Equifax hack. The Equifax, again, a big corporation with thousands of computers everywhere, and they were using this Struts2 component. Struts2, again, a networking component sitting very much in the background. Not many people know about it. It had a security vulnerability, and the community, they got informed about that security vulnerability. It got quickly fixed, so there was a new release, a patch, which was then made available to all the users. However, Equifax was not aware about all the software components that they were using in their environment. They did not have the SBOM. The IT landscape was just running. And because they did not know what they have in use, they also were not aware that there was a security vulnerability with a very problematic security hole, and they were not aware of the fix that was introduced. So they just did nothing. And after 6 months after the patch was released, the hackers found the hole, and they found that Equifax did not have fixed it at that time, and they stole 145 million customer data records. And Equifax, as they do the rating for people who want to open a new bank account or who want to get credit, or they need the rating, so Equifax stores all the data, their financial history, how much loans they have, how good they pay back, their social security numbers, license numbers, passport numbers, whatever you can think of which is needed to identify themselves. So all this data was stolen, and that was a very big hit to Equifax. They were blackmailed, and all the data was released on the internet later on, and that was a big hit to the stock market, to the value of Equifax, and also the upper management. They had to leave because it was all gross negligence of not fixing this issue that was known well before, just because they were not aware of it. So Equifax is one example where you can see it's important to know what is in your software. And not only what you put in your software, the whole supply chain. So also, what kind of open source packages do you use? What kind of open source packages do your suppliers use? I have some more attacks that caused severe damage. MGM Resorts in Vegas with hundreds of thousands of beds, they were attacked, and the attackers managed to encrypt all the IT systems from MGM, so they had to shut down their IT infrastructure, which was not good for the guests in the hotels. So they couldn't enter their rooms anymore. All the key cards were blocked. No new bookings could be made on the reservation pages and web pages. And it took them almost a week or longer to get rid of or to recover from that. And the damage was more than $100 million for MGM and another $10 million for the security companies to fix all the issues again. This is an example just to show the amount of damage that can occur in just a short time, and how important it is that you have a clear view on the risks that you have in your environment. Another example from critical infrastructure, you may also remember Colonial Pipeline attack in the eastern part of the US. I think it's 2 or 3 years ago. Again, hackers managed to break into the computer system, to break into the billing systems of the Colonial Pipeline. So the pipeline owner company could not see anymore who was taking out how much oil. So they had to shut down services, which had a severe impact. And again, it was hundreds of millions of dollars damage in a very short time frame. One last example is a WhatsApp leak that occurred recently. So WhatsApp, it offers, of course, the user interface, and also has a backend API that you can just call as a programmer. And there was a problem that you could request data from that API as often as you wanted. You could read all the customer data. You could read out the whole address book, which attackers did. And at very first, it does not sound very severe. However, what attackers do with this data is they will create phishing mails with the sender will be the account that they hacked, and they will send these mails to all the address data that they found in the address book of that hacked user. So all the recipients will think, it's a friend or a person I know well, and there is a much higher risk that they will open attachments or do something which will help attackers to get into their system. So all of that are reasons that are cybersecurity problems that we currently have in our risk landscape. And to manage that better, many governments have decided we need some regulations and rules. And today we're talking about all of these. And I will just hand over to think Venkat, this is you again.
Thanks, Andy. I think that was a good comprehensive summary of all the known threats that have come into picture, and this is a quick summary of how these attacks on these infrastructure have led into an evolution of all the regulations that we're actually seeing, right? In 2020 it started with SolarWinds, and then and governments, independent entities started taking a notice into what is happening, and starting really investigating on the need to have some kind of regulation around how people produce software. And 2021 is the birth of the US Executive Order 14028. Okay, and this is the first I would say revolution in introducing an SBOM mandate. Okay, so we'll talk about that in more detail, but the whole US government releasing an executive order to produce SBOMs, okay, to work with the federal government, okay, has been a significant shift in how people are perceiving supply chain attacks. And then we had the an attack in 2021, Log4j attack, and this was significant. It came over a weekend in December of 2021, and it really shook up the entire supply chain, where people were just scrambling to find out whether they had Log4j or not. And then we're in 2024, and then we are now sitting on top of not just the US regulation, but we're also having a a properly documented regulation from the European Union, and also some of the regulations coming in India, which are derived by an entity called CERT-In, right? So we have evolved from a state of nice to have versus, hey, these are certain mandatory required artifacts if you really want to do business with a government entity or a financial entity.
Yeah, thanks, Venkat. I think Log4j was super interesting because in my house, and I think it might have been the same for a lot of people that have kids, I learned about it because Minecraft went down. And when Minecraft goes down, those of us with kids find out immediately that the world is not right. And so it just shows you how wide-ranging the problem was, right? And a lot of people were sort of running around going, do we use Log4j? Do we have it? Right? That's by the time it's so public and so well known, it's way too late. So the executive order, it's as I think I said, they came out in 21, so it's been around for a while. What do we know about it? Obviously, it's security focused. I think we know why from the previous slides. The goals are fairly simple, right? We want to remove the barriers between sharing of cybersecurity information, right? That's just government speak for we want to know what's in the code. Improving supply chain security, right? Again, it makes sense, right? You have all of these layers of software, and the government wants to know what's in it. It introduces this concept of a cyber safety review board. Right, probably I don't need to talk too much about it here. And of course, improve the detection of vulnerabilities in government networks, right? That's what it all comes down to. This is security. This isn't license compliance. And of course, wearing my lawyer hat in the room, I don't do a lot of security. I do a lot of license compliance, but they really are just two sides of the same coin. So what do we have now? We have this self-attestation requirement, right? It doesn't apply directly to open source projects, of course, but as we know from that first slide with the iceberg, right? You have open source components in your proprietary product. You have to examine those as well, just as part of your examination of your own code. You need a security policy. There is, and I've been saying this for years, but the estimate for how long it'll take for you to comply with this is laughably low. It's something around 3 hours. That might be how long it takes you to fill out all the forms, but you're obviously going to need more time to have a proper compliance program in place. So we'll talk about the minimum requirements for the SBOMs on the next few slides. So I'm not going to go into a lot of detail here about it. A couple of interesting things though that we get, questions that we get a lot is, when do I have to update my SBOMs? And according to the executive order, it's with every update. Now, is that major version updates? Is it minor version updates? What happens when you have a SaaS solution that gets updated multiple times per day? Do you have to update your SBOMs multiple times per day, right? At some point, you have to figure out what's actually practical and what's possible, as opposed to what does this say, because they don't give you enough detail. At least I don't think they give you enough detail. As far as how deep we go, right? That's another question that we've been seeing for years. On the legal side of this, I've been doing this for 15 years. And 15 years ago, it wasn't unheard of for people to say, well, I know my direct dependencies, but I don't know anything about transitive dependencies. Anything that my direct dependencies are using, I don't have the computing power, I don't have the manpower to go through and find all of that out, right? And technically, that's all that this requires, right? It requires top-level dependencies, with enough info to be able to access the transitive dependency. So it's a little bit more, right? They want to at least be able to find them. But, and obviously we'll talk about this more throughout the presentation, but I don't think that's where you want to stop. That's not really a defensible position, I don't think, in 2026. And again, the goal is to identify known unknowns, right? If there's something in your code that you don't know, right, you have to put that out there into your attestation, right? You have to say, look, we're using third-party components. We went 2 layers deep. We did not go to that 3rd layer or 4th layer or 5th layer, right? Make sure that that's in there. And one key thing here is that you're allowed to keep your SBOM confidential, right? You don't have to publish it on the internet for everybody to see, and that's a good thing, because guess what? If you give somebody who is trying to hack you in the first place a software bill of materials with detailed information about all of the open source components you're using and the versions of those components you're using, it's not super difficult for them to then cross-reference the vulnerability databases and go, aha, I know which vulnerabilities are in your code because I know what you're using, right? So sort of keeping the SBOM a little bit secure is important. And with that, I'll hand back to Venkat.
Yeah, thanks a lot, Leon. I think you covered pretty much, what we wanted to do, on this one, because, we wanted to educate, how complicated it can actually become, to produce an SBOM if you really want to do it right. So, there's a whole lot of fields, there is each regulation actually mandates. That's the reason why we're actually, surfacing this to you, right? You might think that, there's an SPDX file that I've generated, to meet one regulation standard, okay, might not actually be completely sufficient for meeting the EU CRA, for example. So this is just for flash. If you want to take a screenshot. But this is primarily telling us the complexity involved in understanding, to Leon's point, on some people might require dependencies, some people might not require full depth of dependencies, right? But then if you look at the entire US executive order, okay, it has a variety of I would say variants in which people can adhere to the regulation that US government says, which is I would require an SBOM for maybe only critical infrastructure, okay, or where are you in the stage of producing SBOMs? So we could think about that as well, and are you actually following secure software development practices, right? So if yes, can somebody vet on it? So there is a document, like a self-attestation document that the US executive order might say, hey, for all you can just go ahead and give me a self-attestation of secure software development practices. And by no means this is a shortcut to not produce an SBOM, but because this actually requires a lot of legal entities to actually attest the document, and not just the a developer or an engineering manager to sign off on this document, right? So, and then there's a timeline as well. The SBOM or the attestation document has to be presented within a specified timeline, from when the US government asks for it. So a lot of these actually make it both I would say both a convenient and also complex procedure to adhere to the US executive order, right? So with that, let's move on to I think we're probably moving from the west to east. So let's move on. We've covered the United States Executive Order 14028, and I would request Andreas to cover what we have on the European Union Cyber Resiliency Act. Over to you, Andreas.
Thank you, Venkat. Yeah, so for the next slides, we have some details about the European Cyber Resilience Act. It was approved even in 2024, and it's now coming into effect into steps, and we will have a detailed timeline later on. There are two very important dates that everybody should have in mind. And the date when the full CRA comes into effect, that is end of 2027. So very often our customers would think, I have some time left. However, the reporting obligations that we'll talk about in a minute, they come into effect September this year, which is pretty soon. So only a couple of months left. And to be able to report all the cybersecurity incidents that you have in your systems, you need to bear what is in your system again. There are some key requirements, and one very interesting observation is these SBOMs, the software bill of material. We were creating this since 15 years, I think 2012 we started with that. And the first 10 years, the most important question was always compliance, the licenses that are behind there. And that has turned, so now people are more concerned about security vulnerabilities that are associated with specific components. The SBOM looks almost like the same. So again, you have just the names of the components, the versions, where you find them, and the associated security risks. So the one of the key requirements of the Cyber Resilience Act is you have to have your SBOM and you need to manage it. Constantly, you need to monitor, are there any new security vulnerabilities in the open source packages that you are using or that your supply chain is using? And whenever there's an actively used security hole in your product, you need to disclose it. So there are some reporting that you need to do, and I'll explain that in a little more detail in a second. And you are liable for these security defects. So all the companies need to issue patches for free to all their users. And they also need to explain to their users how to get to those patches. The Cyber Resilience Pact is for all the products that are released on the European market. And regardless where they are delivered from, maybe the US or China, whenever it's sold in the European market, then the CRA applies. The penalties are quite high, so it can be up to $15 million or 2.5% of the global revenue of a company. So that penalties are very high if you do not follow the obligations from the Cyber Resilience Act. On this slide, I have put together the key objectives and the key things you need to do. And the first one, cybersecurity must be taken into account for the whole product lifecycle. So from the very beginning, from the planning, the design, development, production, and delivery, this is the security by design. When you start creating a new product, immediately at the same time, all the suppliers need to ask themselves, what can somebody do to attack the system? Is there any way to create something which it shouldn't do, or to break in or steal some data? And in design phase, there is one section called risk management. At this stage, it shall be evaluated. How can you get rid of that, or what can be done that the product cannot be attacked? Then all the cybersecurity risks must be documented. So this is part of the risk management, which is mandatory for the Cyber Resilience Act. And this is part of the design and planning of a product. There is this risk assessment that you need to do. Where are the interfaces? Which components are used? How can attackers enter the system? All of that needs to be documented with an evaluation, how likely it is, and some countermeasures that can be done against it. Then the manufacturers need to report actively on exploited vulnerabilities. So whenever an attacker hacks into your product and he manages to create some harm, or there's an incident that needs to be reported to, there are from the government named agencies. In Europe, it's the ENISA. And within 24 hours, So that's very short. Within 24 hours of the incident, companies need to report that they have been attacked. And then they have 3 days or 72 hours to provide a first workaround or patch for that security incident. And within 3 months, that then needs to be a final report and a final solution. Once a product has been sold, manufacturers need to ensure that for the whole lifetime, plus 5 years after end of life, there's support for security vulnerabilities. So even if you just went end of life with the product for another 5 years, security vulnerabilities need to be provided. Security patches need to be provided. Another important point is clear and understandable instructions for all the users of the product with the digital elements, what users need to do. So there needs to be an instruction, where can they report a security incident? Then there need to be instruction, if there's a patch, how can they install it? And this needs to be made publicly available to the users via some paper documentation or via a web page. That's not defined in the CRA. You just need to make it available. Security updates need to be available for at least 5 years. So the final objective or goal of the Cyber Resilience Act is to make products more secure and to have harmonized rules across whole Europe to make the products safe. And we're not talking about every product, it's all product with digital elements that have a connection to the internet. I have that on the next slide, which products fall under the CRA. So it's all products with digital elements, hardware or software. It can be laptops, smart home devices, mobile phones, network equipment, CPUs, computer games, or software operating systems, word processors, games, mobile apps. So whatever you can think of when there is a digital product that has some connection to the internet. Some other projects are not included, or some other products. Non-commercial products and projects are not part of the CRA. They are not regulated. This is including open source. So as soon as there is an open source project which is not used commercially, then the CRA does not apply. But the company that uses an open source component and puts it into its product, then that company will fall under the CRA. And also, if you have an open source product, very often companies have a business model that they will open source all their code, and then they will sell services on top of that. And as soon as that happens, then we have a commercial activity. So in that case, the product falls under the CRA as well. The CRA is not for cloud service offerings. If you just have a software as a service, if you just put a web page somewhere that offers some services, this does not fall under the CRA. And if you have products that are regulated by some other regulation already, then the CRA does not do a double regulation. For example, in the car industry or with medical devices or aviation products, there are lots of regulations already. All these products are exempt from the CRA. But if they don't apply, then the CRA applies. Sometimes that makes it complicated. For example, if you look into a car, in the car, all the software that is needed for driving the car is regulated by some technical regulations. However, if you look at the infotainment system and all the fancy apps that you can now have in a car, that do not fall under the car regulations, under its technical regulations, they fall under the CRA. So in that case, depending on what we're looking at the car, that falls under the CRA. The European Union, they wanted to make it so only for very critical products, there is a very thorough evaluation and assessment that they are secure. Most of the standard products, you see it's almost 80% of the products fall in the standard category, like smartphones, tech software, vacuum robots, air tags and stuff like that. For that, you can do a self-attestation. There is a list or a checklist of things that you need to do for the CRA, and you can just implement that by themselves, document it, and then declare that you are CRA ready. Then there are products of class 1 and 2, important products that are more risky, like password managers or smart home voice assistants or firewalls, tamper-resistant microprocessors. For these, more rules apply, and it needs to be made sure that they are more secure. Starting from class 2, you need a notified body, an external person, company, certifying that you are compliant for the CRA. And then there are these critical products, hardware devices with security modules or smart cards, secure elements. And again, these need to be testified with a formal certification that you are handling all the obligations of the CRA correctly. So what does the CRA mean? I have put that in 4 different categories. So there are some product requirements, requirements for handling the vulnerabilities, requirements for how you handle your supply chain, and some minimum information that you need to provide from as manufacturer to the users. So if we look at the product requirements, the risk assessment is the start. Whenever you build a new product, you need to do this risk assessment to see, are there any cybersecurity issues that could affect that product. So the cybersecurity is part of the design of the whole development life cycle, and it's called the security by design. And you need to have a secure default configuration. Very often when we look at phones or some devices which have a password, it's set to 0000 at the beginning, or to ABCD. And that's not allowed according to the CRA. It needs to be a secure default configuration, which is different for each device. You need to ensure confidentiality, integrity, and availability of the product. These are the 3 items which are always important in the risk assessment. So when you do the risk assessment, you need to look at the confidentiality, integrity, and availability. So the second section, the requirements for handling of vulnerabilities, you need to be able to receive vulnerability reports from your users or from your suppliers, and or from your open source community. You need to manage that somehow, and they need to be handled appropriately. It's a very short time that you have to either provide a workaround or a patch when there is a serious security vulnerability. And these need to be provided for free. And that may sound simple. If you can, like in a PC, you can just give the patch for download, or if devices, when you can program them over the air, you can just send them to the users. However, if you have embedded devices, that may mean that your users need to come to somewhere to get that installed, and then there's work involved that somebody needs to pay, and that is the company that has issued the software. So some thought needs to put into that the patches need to be provided for free to the end user, and the public information that need to be provided. So the ENISA needs to be informed about active security or active exploit of security vulnerabilities, and they will publish it so that all other companies are aware and can also initiate countermeasures. The third point is this secure supply chain and third-party components in the supply chain. To be able to do a good risk assessment, a software bill of material is needed. And there is also a state agency in Germany, the BSI, and they issue a list of, or a checklist, how a good SBOM looks like, with the component name, the website where you can get it, and they have several items that Venkas has also mentioned in the beginning, what should be part of a good SBOM. There's a duty to take care of all the components that you use in your product. So as soon as a security vulnerability is made public in an open source component, you need to take the patch that has been provided and yeah, you need to assess if you need it, and if yes, then it needs to be integrated into your product. And if you have any customers that use your product to put into other product, you also need to inform them. So the whole supply chain needs to be taken care of. And the minimum information that you need to provide to all your users is this contact point where they can reach you to report the vulnerabilities. It's either an email or a web page or something like that. Then a clear product identification, a number, type, version, and also details about the intended use of the product. And if you have done all of that, then you will get a CE certification. It's a CE sign that can be put on the product. And then all the users know that you are conform to all the obligations of the CRA. The CRA has different variations depending on your role, what you are, and it differentiates between manufacturers, importers, and distributors. So a manufacturer is somebody who produces and builds a product in a company and then sells it and distributes it. The importer would be a company that imports the products from abroad into the European Union. There are less obligations. So the importer just has to make sure that all the requirements from the CRA have been followed by the manufacturer. And then he can import the product. And then there's the distributor who delivers the product to the end customer. He needs to make sure that the importer has made sure that the manufacturer has done all the, followed all the obligations from the CRA. So there are different sets of obligations that apply to each of these three, it's called roles under the CRA. If we look at the timeline, the CRA, the Cyber Resilience Act, was finally adapted in 2024. And the important dates I mentioned already is in September 11th, 2026. So only a couple of months ahead, when all the security vulnerabilities that are actively exploited need to be reported. And then end of December 2027, all the requirements with from the CRA apply. That was a very quick introduction to the CRA, and I will just hand over to Venkat.
Yeah, thanks, Andreas. I think since we're on CRA, I think there's a couple of questions here, in case you're aware of it, otherwise we'll find out answers and get back. But there is a question on this. The CRA seems to make it impossible for new entrants into software or hardware because of the strict guidelines. So the question is more around: is there a minimum revenue requirement for a company to be compliant, or if you're a software vendor, you just have to adhere to CRA?
So what I mentioned, if you have a product that has digital elements that talk to the internet, then you need to follow the CRA. So there is no, just for big companies, or there needs to be a specific revenue. That's not the case. So there are only some exceptions that I mentioned, like if it's an open source product, or if you give it away for free, or if it's regulated by some other regulations, then the CRA will not apply. Otherwise, it always applies. Also for a very small company, even if you're just one developer and sell one product into the European market, which has these digital elements, then you need to be compliant.
And there is one more question, again, I think in the same lines with CRA, which is, what if you have, a third-party vendor that you are working with, a software publisher maybe, and they refuse to provide you updates or patches for any vulnerabilities in the components that you procure from them, or that particular entity has completely gone out of business?
Mm-hmm. So it's your problem. You need to make sure that your contracts with the supplier are updated, so that all your suppliers also follow the CRA. And that's exactly the problem, that we have this supply chain. So as the manufacturer, you are responsible for that all the regulations from the CRA are followed. And if you have several suppliers in your SLAs and contracts, you need to make sure that you reflect all the obligations, like that you're informed within 24 hours. Normally, this is not part of a normal SLA. So, but that needs to be changed accordingly. That you need to provide patches for free. You need to put that into your contracts with your suppliers. Otherwise, you cannot follow the obligations from the CRA. So what if one of your suppliers is not there anymore? Then again, you need to manage it. You need to see how you can replace the obligations. If there is a security vulnerability in the code of that supplier, you either need to get the code or you need to get rid of that part of the code and replace it by something else.
And I think, I apologize, by the way, for dropping off video. It's, hardware problems, not software problems, as always. But I think it's an excellent question. And I think, Andreas, you had an excellent answer, and I just want to add to it a little bit here. This is why when you're getting third-party software, whether it's commercial or open source software, when you're obtaining it, when you're licensing it, when you're getting it, that's the time to do your diligence. Right, you can't prevent a vendor from going out of business, right? That might happen. But if you got your software bill of materials from them before they went out of business, at least you have that aspect of it. Do you have patches? No, right? But do you have more than zero, right? And this is something that people often don't think about, right? They wait for a transaction or some other diligence event before they start collecting all of this info. So I just wanted to get that in there.
Thanks, Leon. Thanks for chiming in. And let's move on to the next one. Okay, so as I said, we keep moving to the east. Okay, and then now we have another regulation coming up from India. So there's this entity in India called CERT-In, okay, which takes care of all government and cybersecurity regulations, mandates, and provides critical infrastructure to the government and ensuring every infrastructure is secure and up to date. So in April 2024, I keep forgetting it's not last year. So in April of 2024, they released a version 1 of what comprises as an SBOM guidelines document, right? So it was a pretty comprehensive document. So primarily focusing towards the financial sector in India. But over a period of time, we expect that any entity that is directly or indirectly associated with the Security Exchange Board of India, or the SEBI as we call it, okay, should actually be adhering to the SBOM guidelines. So this is what we anticipate, and this regulation also has gone through a couple of iterations already. So we'll talk about that in a couple of slides. But primarily, if you look at it, this is a very straightforward regulation that, hey, if you are doing business with the SEBI entity in India, as a financial institution, you need to have an SBOM process, right? Now, it talks about various phases of the life cycle as well, as to when you want to do the SBOM generation, at what progress you are, at what progress you want to actually advance to the next stage and generate the SBOMs and provide it to me. But if you look at it, primarily it is targeting towards the government and public sector, the essential services, and also the software export and services industry, which work with a financial institution that indirectly has a relevance to the Security Exchanges Board of India, right? Now, some of the overview is we're just going to probably do a deep dive as well in the next slide. But some of the this has got the first regulation itself has got a complete list of what minimum fields should actually be used in the SBOM, right? So we have around 21 fields which talk about a variety of software elements, software name, version, supplier, license, dependencies, vulnerabilities, name anything, it has all of that. It also has an interesting field, end of life, okay, which is up for debate in the the open source world, but it also has end of life of an entity written down as a mandatory attribute in the SBOM document. right? And also VEX document, not just an SBOM, but an SBOM which is enriched with vulnerability, exploitability, exchange information as well. And luckily, we do not talk about there is a a third standard. Luckily, the guideline or the regulation primarily focuses on either producing an SBOM in an SPDX format or a Cyclone DX format. And it should be assigned. You should have encrypted storage and other regular audit trail for throughout the life cycle of how the SBOM has to be generated. Right now, it gets interesting when the second iteration of the CERT-In guideline has come in, right? So the second iteration of the CERT-In guidelines, when they came in, they went really all in. And if you look at it, this is what conventionally me, Andreas, and Leon talk about, like an X bomb, right? Which is all things bomb. There's an AI bomb, there's a C bomb, there's a Q bomb, there's a H bomb, and whatnot. Okay, so all of these are also now being included in an addendum in the SBOM. We do not have a deadline for implementing a C bomb or implementing a process to generate an AI bomb yet, but we anticipate that as time progresses, the CERT-In body will start putting in mandates around producing the other SBOM, other bombs, in addition to just an SBOM. Now, this is a quick snapshot. There's not a lot here, but if this is like we have 3 regulations across the world, from the U.S. government, and there is an entire entity on European Union CRA, and then there is an Indian regulation as well. We are also looking at some movement in the Middle East as well on how software is being produced. So there's nothing concrete, and as and when we hear something, we'll let our users know. So what are the real challenges, when we run into, implementing any of these mandates, right? So I'm not going to go through all of this. I think this is, primarily, primarily some infrastructure, some information on, what are the key challenges, people run into when they try to implement a software supply chain program in, their ecosystem, right? And I'm going to probably touch base on, 1 or 2 here, and request Leon for commentary. Is one of the key things that I see with our customers is that culture, right? Because everybody is in a rush to produce more software, but with probably better quality and with better security. But the culture of trying to adopt an SBOM into the entire process is still having seeing a lot of friction, right? And the problem is also with vendors. Like nobody has a single toolkit. There is like a large organization has like 100 development teams, and there's so many development teams which prefer a particular tool set, right? So any quick comments, Leon, on this particular slide, on what you see as a challenge?
No, I think with an eye towards the few more slides coming, let's keep going, and we'll touch on the things there.
Alrighty. And again, this is a typical pipeline of how software is built. But if you look at the bottom purple circles, you see that there is friction across the board, right? So from code building to build process to test to release and distribute. So what we encourage our users, is to go ahead and overcome these at each cycle by if you're at a coding phase, go ahead and find out how you can deal with software supply chain problems with an IDE check. When your build process, how do you have your build process automated, and so on and so forth, right? So as and when you progress through the cycle, so you need to have some kind of a process in place to either produce an SBOM or have a scan process in place which tells you what risk you're running at that particular phase.
Yeah. So you can't see me, but I'm nodding vigorously to agree with Venkat here. So in terms of having an SBOM, so I'll go real quick just to leave a couple of minutes at the end for questions here. I know we've sort of thrown a lot of info at you. There are, of course, carve-outs to the executive order, to the CRA, to CERT-In, right? If you're not dealing with the U.S. government in the U.S., right, you're probably okay. But instead of trying to figure out which exception best fits you, which is, the natural sort of human thing to do, maybe don't, right? Because one of the things that I think is very exciting is We've been talking about SBOMs for a very, very long time. We've been talking about having an understanding of what's in your code for a very, very long time. And software companies want to develop software. They don't want to talk to software compliance lawyers. They don't want to talk to open source compliance lawyers. They don't want to talk to even open source compliance lawyers that used to be software developers. They just want to develop software. Now, right, there's all these regulations that are coming up, and they're sort of saying the same thing that we're saying. So I don't think it matters whether you sell in Europe or not, right? The old joke goes, want to hear God laugh? Tell him your plans. Maybe you will end up selling in Europe. Sales guy comes in and says, hey, we have this huge deal. We want to sign it tomorrow. Clients in Europe, right? Maybe some of your customers are using your products and their products. They're reselling in Europe. They're asking you the same questions. Maybe you have a diligence event, a transaction, an investment, or one of your customers goes, hey, you know what? I've been hearing a lot about SBOMs. I've been hearing a lot about security. I've been hearing a lot about license compliance. What's your policy? What do you do, right? You're going to see reps and warranties in your agreements. You're going to see requests for software bills of material, and you're going to see requirements to produce notice files. And all of these things boil down to just having the information available, right? So create the process, as Venkat said, right? Integrate this into your development process so that you have your record of what you're using and, crucially, how you're using it, right, for where it matters. And that's a whole separate, different webinar that we can do on what information to collect, when to collect it, what are the best practices there, why you shouldn't ignore it, why you shouldn't also collect all the information for every single component that you're using, right? Why that's too much. So I think that's probably it. For what we have for you. I know we don't have a ton of time. I think we left maybe 4 or 5 minutes here, but if there are any other questions, we're happy to get into them. If they're not questions live, we're happy to take them later too. I don't think our contact info is in the slide deck here, but I'm on LinkedIn. You can find me there. And I'm sure Venkat and Andreas are there as well. We love to talk about this stuff. It doesn't exactly make us fun at parties, but it's helpful.
And I've just one sentence to add to Leon to these carve-outs. So why should companies do that at all? Because these regulations, they are not bad per se. They are all good. They have a very good aim to increase cybersecurity. So it's good for your products to follow these regulations.
Yep.
And it will make them more robust. And we had that in the very beginning with all the different attacks that were recently exploited. So it's good to follow these regulations.
Yeah, no, that's exactly right. I get really worried when a bunch of lawmakers get together and make software regulations, right, or do anything with tech, because generally, right, that's the last sort of segment of the population that I want weighing in on what we should and shouldn't be doing with software. But in this case, they're telling you to do something that you should be doing in the first place. Right. This isn't. I mean, there's some quibbles here and there. My understanding of CERT-In, for example, is that there's a requirement to report certain incidents within 6 hours of occurrence, right? Whether data was stolen or not. And either I got that wrong or they got that wrong, because that's just too short a time frame. So there's some issues with them, but I think overall, Andreas, you're exactly right. They're not terrible. They're not telling you to do something that's not good for you. And they're not doing it in a bad way, right? So the ability to keep that SBOM confidential is key.
Awesome. Well, thank you so much, Dr. Andreas, Leon, and Venkat. I know we did take some questions during the presentation, but to our attendees, if we didn't get to your question, we'll make sure to pass it along to the team here and our speakers to get them answered for you after the event. So that is all the time we have. But again, a big thank you to Dr. Andreas, to Leon, and to Venkat for being with us today. Thank you to the audience for attending today's webcast sponsored by Revenera. We hope you all have a wonderful rest of your day.